Alright, boys and girls, I want to just do a quick once over on this assignment. We have to fill in for each of these elements here 3 different columns. Let me go ahead and do the example here using oxygen. Now, this orbital filling diagram, we're used to putting them on an Aufbau diagram that looks like this. Once we have this done, we could change it or rearrange it so that it looks a little more like this. Let's go ahead and just, take a look at how we would go through this. All right, oxygen on the periodic table is atomic number 8, which means it has 8 protons. Now, in its neutral form, it will also have 8 electrons. The positive protons equal the negative electrons. So we would have 8 electrons. That's what I have over here. Oxygen has 8 electrons. All right, on our Aufbau diagram, those 8 electrons would be put first into the 1s shell. All right, they're spin paired. That's 2 electrons. The next 2 would go into the 2s. That's a total of 4 electrons. And then we would have 5, 6, 7. All right, we don't pair the electrons unless we must. That's called Hund's rule. And then the 8th electron would have to form a pair within that set of 2p orbitals. Remember, p's come in groups of 3s. So that's 2, 4, 6, 7, 8 electrons. Now, if we take that, we could transform it from a vertical representation to a horizontal. Notice they have 1s and then the up-down arrow, and then a comma, and then they show the 2s. All right, so we've got that one shown. Now we're going to show the 2s next. That'll be right here, 2s up, down, then a comma, and now the 2p's. All right, notice for the 2p we draw 3 lines, boom, 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 and then we draw the electrons that are in there. So we've essentially just taken this format and just put it all down on one line. All right, so the 2s would be here, and then the 2p's get moved down here. All right. Okay, the electron configuration portion of it, we're familiar with that, so I'll just skip that. We just write these out without showing the arrows. Showing the arrows in the Aufbau diagram. We just write in the number of electrons. So in the 1s there's 2, in the 2s there's 2, and in the 2p there are 4. So we write it 1s2, 2s2, 2p4. Now what about the electron dot? All right, it's only the outermost energy level electrons. All right. Now if we go back up here, these guys right here are the outermost energy level electrons, the 2s2, 2p4, and that has 6 outer electrons, also called valence electrons. 6 valence electrons. All right. And it is those 6 valence electrons that are used to construct an electron dot diagram. All right. So we take the symbol for oxygen, O, and we surround it with 6 dots. All right. Now the way we do this, start fresh. Here's the oxygen. We have to put 6 dots around it. All right. I assume it to have. Let's see how we could do this. Assume it to have like 4 quadrants. Excuse me, 4 quadrants around it. It's got a top, a bottom, a left, and a right. And I could put 2 dots in each of these positions. So I'm going to put 1 dot in the top quadrant, and then 2 here, the 3rd one here, the 4th one here, and now the 5th dot I could pair up with the one up top, and then the 6th dot would go right there. All right, and that is exactly what I have down here on this thing. All right, let's just real quick do boron. Boron is, let's see, atomic number 5, so it's got 5 valence electrons. All right, let me write that down here. 5 electrons, not valence. 5 electrons total. All right. Now, on the orbital filling diagram, I would put the first 2 electrons in the 1s, the next 2 electrons in the 2s, and then 1 electron in the 2p. All right. Now, from yesterday's discussion, we should have figured that out just by looking at the position of boron. It's in the first column of the 2s block, so its configuration should end with 2s1. Right. So anyway, we're going to take that and move it over to this to the paper here. So it'd be 1s, and then we put the electrons in like that, comma, 2s, up, down, and then 2p, and there's 3 of these lines here, because p's come in groups of 3, and we'd have a single electron there. All right. The electron configuration would be 1s2, 2s2, 2p1. Now, what does the electron dot look like? Well, remember, we want to symbolize around this, the boron symbol B, the number of outer or valence electrons. Well, for boron, that's these guys. Right? What we're going to be looking for here is the highest energy level numbers that are part of the configuration. So the highest energy level is number 2. So that's going to include the 2s and the 2p electrons in this case. Well, when I add that up, that is a total of 3 electrons. Right? Here, the total number of outer electrons is 3. So I'm just going to have to take this boron diagram and draw 3 dots around it. So it'd be 1 on top, 1 to the right, and 1 on the bottom, and there you go. Alright, hope that helps, boys and girls.